I bought more junk. This time it's apparently a 50-60 hertz 12 amps? No, did I get scammed? No. Okay, so what this is apparently a 60 watt solar street light, as you can see, and there is no connectors on it, so why the hell does it say 50 to 60 hertz 12 amps? That's weird. Maybe they do. Maybe they're making 220 volts version of these. That would be interesting. Anyways, I was hoping, I bought this, I was hoping to make sort of a big live teardown and review of this thing. I didn't actually just buy it for the review, I wanted to steal some ideas for one of my upcoming projects, and nicely under all of these peels it has the screws, so it should be easy enough to take apart. But they said this is the most powerful one, and it does look bright on the camera, but it might produce what, 1,000 lumens at best. And if you cover this thing, toilet paper. Yeah, it cuts down, and this is the brightness level that it maintains through the entire night, and this is like I would say 500 lumens at best, which is really not a lot. And it's so this thing are actually a really crappy light source, so even though they are quite cheap, this thing costed like 35 euros. That's pretty much why you don't see them lighting up our streets. Imagine driving down the road, and as you're driving alone on the road, you just see lights dimming in and out around you, and yeah, it would be really crappy. So the only purpose of this passive infrared sensor is pretty much to make the thing barely last in the entire night. Although apparently the seller said it could survive 2 nights of light without charging, but I highly doubt it. So let's have a look inside, shall we? Oh, that's nice to know. There are holes here and there is no waterproof seal, so this thing probably wouldn't even survive in the wild. So here we have the battery, which is actually quite a bit bigger than I expected. We have direct contacts to the solar panel, so I can do some testing to see what are actual characteristics of this solar panel, because it sure as hell isn't 60 watts. We have contacts to the lamps, to the actual diodes, so they are likely all just in parallel. And this is a 3.2 volt battery, and they appear to be in parallel. 3.2, what is that? That's not a lithium ion battery. Let me try to Google what that is. Okay, so it is apparently a lithium phosphate polymer 4 battery. So that's the new safer alternative to lithium ion. So that's That's kind of neat because this is a plastic casing actually, so I don't think it would fare well with flame exposure. So let's have a look at the actual circuit board. Okay, so this is the actual circuit board. I don't have a printer, so I cannot print it like Big Clive does. But pretty much what we have here is, from the back side, it's a big ground plane. We have LED plus, LED minus, solar plus, solar minus, battery plus, and that's the big green switch that we saw on the other side. So that would be, it goes straight to the battery positive, so that would be a good place to do some current measuring to see how much these LEDs actually draw and how much the solar panel produces, because I would like to try to avoid breaking this thing. The other side of the circuit board, the first thing that caught my eye is that the actual infrared sensor is straight up missing. There is plastic for it, and there is the what you call a lens for it, but the actual thing is missing. And this chip right here does not have any markings whatsoever. Here is the big switch. There is an LED which lights up when you turn the thing on. See, it glows red. But now I'm confused because it does react to my radar. Oh, so does it sense my presence? It might be working using the radio interference. There are many capacitors in series that you can probably use to tune the frequency or something. Okay, yeah, I legitimately don't know how the sensing works, but I can tell you for sure that it does respond to my movements in front of it. Smart low side power switch. Okay, so this yeah, I can't say that I know what this thing is doing. The other one is 7830-1. I don't think I'll find anything there. So it appears to be a small 100 milliamp regulator with multiple possible voltages. This being an 7530, 7530, so we have a 3 volt 100 milliamp regulator. This right here, there is a diode connected to it, so this thing is very likely a microcontroller. This thing is probably a sensor of some sort because it says radar. I'm not entirely sure. I cannot tell. On the other side, We have diodes. Okay, so those diodes are on the input of the solar. Okay, so we have a solar input going through the two parallel diodes to the positive of the battery. And then we have, yeah, that would be LED negative and LED positive right here. So from the battery positive, it goes directly through the 4 resistors to the LED positive, and LED negative, which is this plane right here, goes through these 3, they are probably MOSFETs, to the battery negative, and the drive signal for these 3 MOSFETs goes to the controller. So interestingly enough, the current going to the LEDs does not go through the switch. The switch just controls whether or not the microcontroller circuit is turned on or off. And the current to the LEDs is limited with these 4 resistors. And the current going, the battery charging current is only limited with the internal resistance of the solar, because there is nothing between the solar cell and the battery contact other than the diode, so the voltage from the battery wouldn't go back to the solar and kill the solar cell, because yes, that is what can happen. So that's it. I mean, there's not much else I can do. Here is one more look of the entire circuit. This is the front side. No, this is the back side. And that's really odd, I must say. Really odd. And there is a capacitor going from the regulator to the pin that goes absolutely nowhere. So this capacitor is not even connected anywhere. That's weird. That's really weird. That's really weird. Oh, it goes to the middle pin. Shit. So, oh, it goes to the middle pin, and middle pin goes to the ground. Okay, so this capacitor might be doing something. It's the bypass capacitor for this regulator. Okay, so other than that, now let's try to take apart one of these LED modules to see how it is constructed. Okay, so here's the plastic front. Here's the, oh, okay, yeah, as I said, they are in series. This is the reflector. This is the module itself. The modules we can see are all in series. We can see that, yeah, so positive goes to here, 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 and here, and negative pretty much goes to all the other sides of these LEDs. So all of these LEDs are in parallel with each other. Okay, so let's try to do some measurements. I don't know why autofocus doesn't work on my camera. I have to manually adjust focus every time. So let me cover the LEDs somehow. Small something like this. Okay, so we have light. Let there be light. We measure the voltage across the battery. The battery is at 3.09 volts. The voltage going to the LEDs is 2.67 volts. Can I measure the current? $200. So I will just turn off the LEDs and jump the MOSFETs. Oh, it's over 200 milliamps. It's 1.3 amps at full power. 1.3 times 3 volts, so 1.3 amps times 3 volts. We have 3.9 watts of power. That times the an average LED bulb does around 100 lumens per watt, so times 100 lumens, we have the entire lamp. This entire lamp is producing about 400 lumens. So yeah, it's a 4-watt lamp. It's producing 400 lumens. That's, last time I checked, a bit far from the full 60 watt it claims. Yeah, though I want to see how much power it is drawing from the battery when the light dims down. Now obviously I cannot just stick my multimeter in a series with the LEDs because it's almost definitely a PWM signal, so that's going to be a bit tricky. Let's cut the positive wire going to the battery. Let's sharpen the wire. Sharpen the other side of the wire. Now I can technically just do this right now. Turn it on, of course, and it will turn on and read 1 point. Oh, it's reading a bit above, so it is about 4 to 5 watt lamps, 4 or 5 watt lamp. So right now it's reading 1.46 amps, but I don't think it will be accurate once the lamp dims because it's still a PWM signal. So what I will do is I will solder a capacitor in parallel with the board with the battery connection to smooth out the current flow a bit. And now I should in theory just be able to measure it. Now of course any normal person, engineer or anything would just grab an oscilloscope, measure across these current limiting resistors and just calculate the power going through to the LEDs, but I don't have a proper oscilloscope, so this will have to do as a DIY solution. Okay, so 1.5 amps at full power. Now we wait for it to dim down. And 0.32 amps. So 1.5 times 300 1.5 amps times 3 watt times 1.5 amps times 3 volts, which is the current voltage of the battery, and we get 4.5 watts. So each of these modules is using about 1.5 watt. Now typical LED produces about 100 lumens per watt, so times 100, and this thing is producing about 450 lumens. And when it dims down, it draws 0.3 amps times 3 volts. It consumes about 0.9 watts, that's 0.3 watts per module, times 100. The entire lamp is producing about 90 lumens. This is a really crappy light source to light up anything, and especially the roads. Also, I'm not entirely sure what black magic this board is using to detect movement, but I don't think these light poles are usually about 10 meters tall, so I don't think it would be very effective at detecting anything anyways. These things are mostly used to light up entrances to garages and stuff, to light up advertisement panels and things like that. Now currently there is no sun outside, so I cannot test the solar panel, but I will do some measurements and hopefully put them at the end of the video. So instead of 60 watts, it's using only about 4.5 at maximum, and I don't know why it says 12 amps and 50/60 hertz, because that's obviously bullshit. And that's about it. I'll now put this thing together. Okay, anyways, here's the lamp all put together. Here are the wires going straight to the panel, and yeah, next time the sun comes out, I'll do a few measurements and I'll show them. And that's about it. So after the previous video, I just couldn't get the thing to turn on again, so I went to investigate, and then I realized now that's a nice design. It turns out this plastic is pressing on a button, even though it does click, it's not making a connection. So that's sick.